In the in this lecture, we start another chapter of C++ book, that is arrays. In this lecture, we learn arrays, one-dimensional arrays, example of one-dimensional arrays, and copying arrays. Let's have a scenario. We initialize 7 variables with the same data type, that is integer. So we write int a, comma b, comma c, comma d, comma e, comma f, g, h, I, and j variables. These individual operations input is needed for each variable's mean. If we want to use a, b, c, d, e, f, g, h, I, and j variables, for each variable we use a separate cin statement or cout statement in our programming. Instead of using a separate cin or cout statement for each variable, which is a time consuming process, we have a better solution, that instead of using cin and cout for each variable, we use loops. In loops, one variable will be enough for the all input values. But we have an other issue when we're using loops for the issue is that it is impossible to access or recall the previous variables after executing if we need to perform another operation on any previous variables. In loops, when we use a single variable for more than one input values, then we update our variable after each iteration of loop. So it becomes impossible to access or recall the previous entered values. So we have another best solution. The best solution is declare an array variable that will allow us to store values in contiguous memory locations, perform some operation, and still have the control over previously accessed values. This principle is what we call an array. So let's have another problem. Suppose we need to store 100 roll numbers. Then we need to declare the 100 variables to keep track of each 100 students. Accessing variables is also difficult in this case. All the variables are also stored at random addresses in the memory. So instead of declaring roll 1, roll 2, roll 3, we can directly declare roll bracket 100, in which roll 1, roll 2 are considered as individual variables. For this scenario, let's start the programming. In the main program, we declare std1, std2, std3, std4, std5, 5 variables with same data type integer. Then we write enter marks of the students, and we write scene, and we use these variables to store marks of the students. Then we calculate the average marks of these students. We use we declare another variable average marks with the data type of float, and we add all these std1, std2, std3, std4 and std5 variables and divide it over 5, so we get the average marks of these students. Then we write cout average marks of the student and we print our marks on the screen. But if we have more than 5 students, then we update our program as instead of 5 variables, now we declare 10 variables. We write int std1, std2 up to std10. Then we write enter marks of the student. Then we use scene, and for all these variables we use to store the number of 10 students. Then we use the same formula to calculate the average marks. So we declare a variable average marks with a data type of float, and we sum all these marks and we divide over 10. Then we shows the output on. So here is another scenario that what will we do if the number of students are 1000 or more than thousands. It creates a big problem for us in this scenario. So it is time consuming process to use these variables individually. This process can be simplified by using arrays. So the solution is use arrays. So what is an array? An array is a data structure that stores an element of the same data type sequentially. A C++ array has a fixed size. We can see an array as a collection of variables of similar data type. Instead of declaring each variable and assigning it a value individually, we can declare one variable and add the value of the various variables to it. Each value added to the array is identified by an index. So arrays are very important in any programming language. They provide a more convenient way of storing variables or a collection of data of similar data type together instead of storing them separately. Each value of the array will be accessed separately. So arrays in C++, arrays are data structures consisting of related data items of the same type. The memory location in the array are known as elements of array. The total number of elements in array is called the length of the array. In array, to refer to a particular location or element in the array, we specify the name of the array and the position number of the particular element in the array in square brackets. The position number is more formally called a subscript or index number. A subscript must be an integer or integer expression. Array is a linear data structure. It can store fixed number of values. Arrays in C++, the rules of variable naming convention apply to array names. In C++, each array has a data type, a name, and a size. Data type It indicates the data type of the values to be stored in the array. Identifier or the name, it indicates the name of the array. Length or size, it indicates total number of elements in the array. It must be literal, constant or symbolic constant. The array occupy the memory depending upon their size. The first element has subscript 0 and the index of the last element is length minus 1. The value of the index is written in brackets along with the name of array. The highest subscript in array is 1 less than the number of total elements in the array. So when we declare an array, we use data type identifier and into the brackets the length of the array. So in this picture we clearly see that the position number of the elements within the array are 0, 1, 2, 3, 4 up to 9. These 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are called the index values of the array. We use these index values to get the original values stored in the array as std array 0 stores a value 10 into the memory, std array 1 stores a value 20 into the memory, and std array 2 stores a value 30 into the array. Similarly, up to std array 9 stores a value 100 into the memory. So address of first element is random. Compiler assign it randomly when we declare the array. So, but the address of the next element depend upon the type of data type of array. For example, if we have an integer type array, then it takes 2 bytes in the memory. Therefore, every next address will increment by 2. So in this figure, the reference address is 48252 is assigned randomly to the first element of the array, and the second element has the address 48254, which is an increment of 2 from the previous value. Similarly, each value 48256, 48258, 48260, we see each value has an increment of 2, and the index of the array is 0, 1, 2, 3, 4, and these 0, 1, 2, 3, 4 store the values 78, 45, 12, 89, and 56 on the respective positions. We have some advantages of an array in C++, which are array can store a large number of values with single name. The values stored in the array can sorted easily. The search process can be applied on array easily. It can be used to implement other data structures like linked list, tags, quiz, trees, graphs, etc. And 2D arrays are used to represent matrices Random access of elements using array index is very easy. Use of less line of code as it creates a single array of multiple elements. Easy access to all the elements. Traversal through the array becomes easy using a single loop. Sorting becomes easy as it can be accomplished by writing less line of codes. So far, what we learn in this lecture is summarized as that array is an data structure as a is collection of elements of same data type, or we can also say that array is collection of variables of same type. Array stores the elements in sequential manner. Array elements are accessed randomly using the subscript of index variable. Array elements consist of contiguous memory locations. Lowest address of an array corresponding to the first element. Highest address of an array correspond to the last element. An